So yeah, all these are just means to try and strengthen our partnerships and make sure that we are bringing value into Eswatini as well. So yeah, in a nutshell, that's about AI Eswatini. There's a lot that is going to be happening. And yeah, we are really excited about this project that we're doing currently, and the response as well that we've been getting in these initiatives that we are introducing into Eswatini. So thank you so much for attending. Thank you so much, Samkelo. Over to you.
Thank you so much, Mr. Malaza. Thank you so much. If someone has questions, you can ask them at the end of the session, or you can drop them in the chat. For now, may I please present this opportunity to Mr. Johnson. Mr. Johnson, over to you.
Hello. Hello there. Can you guys hear me?
Yes, yes, we
confirm
can.
sound. All right, that's good. That's good. Okay. Yeah, thank you very much for this opportunity. And on behalf of the whole of Eswatini, so I didn't really know much about Eswatini, but I'm glad I now know. I didn't even know the country Eswatini exists, to be honest. not enough, not to be funny, but it's really something that I think that has added on to my understanding of the world this year. Yeah. So my name is Johnson Mahmoud, a software engineer, a full stack developer in AI, machine learning, and also venturing into Web3. Yeah, so I currently work for a company called Digiverse Solutions, and it's more like a software outsourcing company where we build softwares for different organizations. Yeah. So right, if you can just jump into what we are meant to do. Because if I'm to talk about myself, I think I won't end. Yeah, so I believe, I can, I think, share my screen, right? Okay, let me try to share my screen.
Yes, please do.
So that you can see. Yeah, just a minute. Is it shared? Not yet.
Not yet, not yet.
It's coming. How is it
Yes, 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 now.
there? All right, you can see it, right?
Yes, yes, we can.
Okay, nice. All right, so I believe, okay, we may have some people who have been getting started with mastering AI, because I'm sure some of us have experience, some of us are mid-level, some of us are experts, some of us are just seeing this for the first time. And you're going to at least pick something for this session. And so this session is about reinforcement learning, and I'm giving you the fundamentals and its applications and the future, right? Where to use it. So first of all, what do we all know about reinforcement learning? Yeah, I believe all of us who are here have at least attended the previous sessions. Okay, I believe some of us have attended the previous sessions, and we've seen about
Sorry, Mr. Johnson. I think you are not audible.
Hello, can you hear me now?
Yes, we
Hello?
can. Yes, we can now.
Someone actually muted my mic. Someone actually muted my mic. Sorry about that. All right. So when we know about reinforcement learning, we've heard of supervised learning. Yeah, supervised learning is more like dealing with labeled data, whereby models are learning from labeled data. It's like a teacher that's giving you like correct answers. Yeah. So you learn by copying those right examples from the teacher. So you're learning from something that's already there. It's like reading a marking guide that already has answers. So you have all the answers there. You're learning, but you're seeing everything. Yeah. Then of course, unsupervised learning, uh, whereby you're learning with patterns, and here you're exploring, right? You don't deal with labeled data, but unlabeled data. Yeah. You're exploring, like nobody tells you what is correct. You just discover your patterns by yourself. Right? So that's how supervised learning and unsupervised learning happen. But now when we come to reinforcement learning, here we are dealing with agents. And these agents usually deal with, they make these decisions by interacting with the environment. Yeah, they interact with the environment to like maximize accuracy, to reduce errors. So in other words, reinforcement learning is more like try and error. Yeah, you try out something, it gets an error. You keep on training and trying it out until you improve and resolve the errors. Yeah, think of it like actually I like using a game because games are related to more of like robotics, and they deal with learning. Yeah, like if you're playing a game, you learn by trying out things. Let me say you're playing a video game, you're trying out something, and you make mistakes. You make mistakes. And while you're playing the game, of course, those mistakes you make, you want to go back and start afresh. Then you come back to that place where you made the mistake and pass through, you get, and go to the next level. Yeah, so it's more like playing a game. And usually when you're playing a game, you also get rewards. Yeah, there are points you get. You can either get a penalty for doing something wrong in the game, and you learn what works, yeah, through experience. So you gain experience while playing that game, and the more you gain experience, the more you become good, right? So that's how reinforcement learning works. Yeah. And well, as you can see, we have the flow of how the reinforcement model goes. We usually deal with the agent. So in form of a game, the agent is like the player, right? You who is the player. So you're the player and you're the one who makes decisions while playing, right? So when we move to the actions are more like the directions in the game. You have the left key, the forward key, and you have the jumping. You can run left, run right. So those are the actions in the game while you're playing, right? So we have the environment. I think of an environment as the things that are in the game. Yeah, let me say you're playing a game, but it has buildings. Like I believe most of us know like that game called GTA, Grand Theft Auto. Yeah, so if you're playing that game, it has buildings, can have doors, it can have obstacles. So those are like the environment you're dealing with, right? Then, of course, as you're playing that game, you get rewards. Yeah, there are some levels you can go to, you collect points, grab something, maybe in case you've beaten someone up, you get a reward, right? Then, after receiving that reward, then it goes back again to the agent. So those things that have been done throughout that whole process, yeah, you've done them, but whatever you've done from agent, action, environment to reward and back to agent is there's something you've done through that whole process. And this whole process has allowed the model to get trained and learn something. You get, because all those moves that you've taken from that point and the points you've gathered, yeah, you want to do it again. You want to do it more and more and more. then while you're doing it more and more, you're avoiding the obstacles that you faced. Yeah. Let me say the obstacles that you faced before. So it ends up becoming a trained agent, yeah, from something that was nothing. Yeah. So these are like the core components of reinforcement learning. As I explained before, you have to have the agent. The agent is, as I said, you're the person who is interacting. Then you have the environment, that's the surroundings that you're dealing with. You have the action, those are like the emotions you take, you anticipate during the game. Then there's a state. State is more like the current situation, and that very situation you're dealing in, yeah, because there are different states, and I'll explain that later. So then we have the reward. Rewards are always the feedbacks that you get from what you've achieved. Then, of course, there are policies. Those are like the strategies now that you use to choose the actions that you're making. Yeah, yeah. So how this reinforcement works is it first of all it deals with observation, right? So in this case, this is just now how the models work, yeah, in the background. So like if there's observation, the agent is going to observe the current state of the environment. Like it wants to like figure out like what's my environment, yeah? What people or what things am I dealing with, yeah? So when it realizes the kind of environment it is in, it makes a decision, but that decision is based on a policy that the agent selects an action to perform. Yeah. So the decision it makes is based on now you, the agent, what action have you selected? Yeah. So that decision comes from the action that the agent has selected. So if let me say action, the agent says, you, the agent, wants to move left. Moving left is an action. So the decision it will make, it will move left. Yeah. So that action is executed. It's executed based on what? On the agent. So the agent decides, it decides to make the action, then the decision is made to move left based on the environment. Yeah, then feedback is now how the environment transitions to a new state. Yeah, like I explained already about the game situation. You're dealing with a game, you're moving around, and you find a door opens, then you enter into a building, and maybe you find a box that you're supposed to pick up. And when you pick up that box, you what? You're getting a reward. So in other words, you're interacting with the environment. Yeah. So in this progress, everything interconnects. Like these things all work hand in hand. The environment should always be there. The agent should be there. Actions should always be there. That's how the model lands. That's how it gains like experience. Yeah. So when you gather the feedback, the learning begins. So this is where the agent updates its policy to maximize the feature reward. So during all those actions that there can be around 1 million actions involved, yeah, just for one agent to capture one specific thing that it has learned. Yeah. So it keeps repeating that cycle, and it's a loop, by the way. It's a loop that continuously goes on. So the goal here is just to learn and to achieve an optimal policy that maximizes expected cumulative reward over time. So you're training something to become perfect. Yeah. You're training it to like become as I'll explain in the next parts, you see where applications of this happens, where you can use these trained models and they really get accuracies that are way better, and they can even go beyond like what a human can ever imagine. Yeah. So these are the types of reinforcement learning. You have model free and model based. Yeah. So in model free, we have we have the agents, where this is where like the agent learns without building a model of it. So the agent is simply learning, but they're not building any model of the environment. Yeah. In other words, okay, this is more like the agent learns, but it's not building anything. Yeah. Now, to understand this better is let's look at like Q learning, for example, because we have Q learning, we have SASA, we have policy gradient methods. So if like Q learning specifically, let me say here actually you're learning by doing the best move. Yeah, it's learning by doing the best move and trying out things by remembering like which moves gives the most points. Like for example, in a game, yeah. So if you're playing a video game, you try every move in different places, yeah? And you write down, let me say, you can note down like, no, I did this move in this place and it worked. Then I did this one and it also worked. So it notes down those things using Q numbers, yeah? And after noting them down, that means the next time you have to look into those notes to like choose what's the best move for a specific area, yeah? So that's like that's more like the Q learning. You don't really need to first build the model of environment. No, you just have to first do a move in a specific area, then you note down. Yeah. So that's simply how the Q move works, and it's used a lot. Anyway, I'll ask questions, and I hope you guys can answer and give me like some scenarios of what you think about applications of QMove and how it works. Yeah. Yeah. So that's how the Q learning works. So when we talk of SASA, I believe if we have machine learning people or I believe guys have implemented this or like used it somewhere. Yeah. So this is also another model free, and SASA is very good because for it's one of the nicest things because it learns by trying out the best moves. Yeah, it learns from the moves that you've actually made, even if they are silly moves by the way. It learns from them. But so like SASA, if you try to risk a move while you're exploring, let me say again, and you try to risk, yeah, it will learn also from that risky move. So it learns on policy. Yeah? It has a difference learning, some kind of learning. So for it will basically learn from the moves you actually make. Every move that you make, it learns from it. Yeah. Then for policy gradient, for it's more like it goes straight to the point. Like for it doesn't waste time. Like it's direct. Yeah. So that's why I say it directly optimizes the policy. So it goes direct to the point. Let me say it teaches you actually. It's the one that teaches you to choose the best move. Yeah. Like imagine you're playing a game. It's the one that just tells you this is the best move. This is the best move. It's like I think some of us have played this game called actually chess online, right? Is that chess that is played online. Like for those who are beginners and they don't know chess, sometimes they can just tap their assistant and it helps them like figure out the next move that like the moves that they can make. Yeah. So it's like it just gives you the best move directly. Yeah. So for model based these ones simply based on the agent builds on an internal model of how the environment works. Yeah. So here you're building something like it's internal. Like you don't you based on the environment, but it builds it internally. I don't know how I can bring this out, but I usually like explaining with examples. So if you're looking at like the DynaQ, the DynaQ, the DynaQ model is a model based, and for it learns from real experience, yeah, and imagination. So otherwise it combines the learning and planning. Okay, back to again our games. Yeah. So let me say you're playing a game for like 5 minutes. Yeah. Then you sit back, let me say, and you pretend to simulate more moves in your head. Yeah. Yeah, like let me say you're playing a game, then you want to simulate some moves in your head. So what the DynaQ does is it uses real experience, like real, let me say you're playing any game. It can be I don't know guys who play like Call of Duty, those kind of games. So when you're moving like the character in the game, some things you can actually imagine that you can do. You've never seen them happen in the game, but you just imagine they can actually happen there. Yeah. So in other words, that is how DynaQ works. Like it just uses real world imaginations. So Monte Carlo, for it, it's used in gameplay. Actually, it's used a lot in gameplay, and for it, it's like so for it works like you have to look ahead into the future. Yeah. So you have to look ahead into the future before you choose any move that you're doing. So in other words, if it builds something like a tree, yeah? That's why they say it's a Monte Carlo tree search. So it has so it builds something like a tree. A tree of future moves. Let me say you have like moves that you expect to happen in the future. So you build a tree of them. So you try out the moves each from the first branch of the tree going downwards. Eh? Then you see what can happen. Yeah, you see what might happen. Then you keep on trying while you're moving downwards for each root of the tree that has been established. Yeah, and until it chooses the best path actually, because usually like if you have like a tree, if those who know like the first search algorithms, all those algorithms, right, of data structures, you know how the DFS works. So you sometimes look for the best path after testing out all paths. So it's tree based, and for you just have to like choose what is the best. You try out everything and choose the best. All right. So these are the algorithms that are used. These are some of them. There are very many others, but these are just a few. So the reinforcement algorithms, there is the deep Q network, as I explained already, deep Q. Then we have the proximal policy optimization. So this is the PPO. For it is stable and efficient. So this one is just to like ensure like everything is in optimal state. Like there are no there are no there are, there are no crash outs, or everything has to be flowing. Then we have the actor critic. This one just combines value-based policy methods, right? It combines them. Then we have the A3C. I think these ones are better to like show when you're working in something really, show like how they work. Yeah, then there's a TD3, there's the SAC. So these are all algorithms. You just have to like choose what really works based on what you're building. Yeah, you apply them to whatever you're building. Yeah, so the classic examples of the reinforcement learning, of course, game playing comes number one. Actually, they use reinforcement learning a lot when they're building these video games that most of us sit back and enjoy on our computers and consoles. Yeah. So even in robotics, of course, robotics, you know, like those robots that Elon Musk keeps building, most of them are based on reinforcement learning because they are try and error. Builds a bot, let me say a bot that has to act as a maid, and it has to keep learning all the actions that a maid does in a house. Yeah. So it's all done. Then there's autonomous driving, you know, those ones, the self-driving cars, they have to also keep learning as they discover new routes, as they get on the road. They make errors, they learn from the errors. Then also in finance, it's also applicable, especially in like those risk assessment strategies, like maybe say you're managing someone's portfolio and you identify like, let me say, loopholes in portfolio. The model can actually be trained to like manage finances for someone. Yeah. Then it can allow you manage your finances, but of course, in case you let me say go astray from what you're doing in the financial bit. Let me say you are supposed to spend $600 today and you end up spending $800, means you've broken the rule. So the model will have to alert you that you're not doing the right thing. But the more you do it, the more the model is going to learn that that's what you do always, and that's what it's going to comply to. Yeah. Then also other recommended systems that exist. So moving on to applications. Of course, we apply this in so many things. In the healthcare sector, where I can get personalized treatment, planning, and drug dosage optimization. Yeah. Okay. So then there's medical image analysis and diagnosis assessment. Then there's robotic assistant surgery, like those robots that actually do surgery, whereby humans don't have to actually be in the place. And they're the ones that operate. So the robot is trained to be like a doctor. Yeah. Then in the manufacturing and supply chain, it can be quality control and maybe defect detection, maybe a production scheduling, resource allocation. Like the model is trained. Actually, these models are trained to like do tasks that we do in our everyday life, and they are meant to perfect them. Yeah. The energy and utilities, where we have like smart grid management and energy distribution. We have heat, ventilation, and air condition system, which optimizes in buildings. Then wind turbines. Yeah, those are usually in airs. Natural language processing, NLPs. These ones we have the machine translation improvements, text summarization generation. Like if you want to summarize text, these are more like the models you use in ChatGPT. Yeah. So what reinforcement learning can do? Yeah. We can have sequential decision making, and by sequential I mean like it makes these decisions step by step. Yeah. And it excels at each problem that it finds along the way. So reinforcement learning is based on try and error. So you try something, it fails, it tries it again, it fails, tries it one more time. It doesn't matter how many times until it passes that test. So after passing that test, he has already learned it, and that sticks already. You will never unlearn it again. It will just keep learning and building on until it forms a whole combination, some kind of neural network that combines all the learning models it has gained. Yeah, so you can also learn without explicit labels. Then you can adapt to the dynamic environments. This one actually it's continuous. This one is the one that deals with environmental involvement. So in case of model is learning, let me say it's a robot and has been put somewhere, it has to learn based on the environment it's in. It has to see the people it's dealing with. It has to see the buildings it's in. So environment is very important in reinforcement learning. And also handling complex state spaces. This is where, by the way, there are deep learning models. Deep learning models handle complex things. So they're the ones that maybe like can process like high dimensional inputs. Let me say like those CNN, if those guys who know about CNNs, that can read an image and maybe analyzes the image and gives you a detailed explanation of what that image is. So those are like those are like core models, maybe like large vision models. Yeah, yeah. Then you can also discover novel strategies. It can find creative solutions that a human might not consider. So reinforcement learning is it's one of the machine learning strategies that are used in complex things, right? Like this is where you can train a robot to reach, even do certain things, and it gains creativity as it learns. So in other words, it's becoming intelligent. And the more it gets intelligent, the more it starts giving you surprises. Starts giving you things that you never imagined it would do. Yeah. And that's the whole point about reinforcement learning. So everything has its downs, and everything good has something bad around it. So the challenges in this, it can have a sample efficiency. Yeah. By sample efficiency, I mean it requires many interactions to learn. So you really have to be like giving it a lot of, you have to be feeding it with a lot of things. If you want to train something to do exactly what you want, you really have to feed it. And usually these things come costly, and they also consume time. I believe some of us here who have done a bit of data science and ML, you've trained some models, and there are some models that can take hours and hours. You can take a lot of hours to train a model, and you've just achieved, let me say, 5% of the model accuracy. You get? So yeah, those are some of the challenges, but everything nice takes time. So it's just a matter of patience. So then the reward design is defining the right reward function is also crucial, because you know, if as I explained earlier, you go through the agent, you do the action, then you have to also reward the agent, right? Because when you're rewarding that agent, you're motivating it to do more. Yeah. So getting the right rewards may also be tricky during this whole process. Then exploration versus exploitation, that's like balancing the new actions. Then the stability, this involves like training. Actually, stability here is when you're training a model, and sometimes models are like they're unstable, like they crash on the way as you're training. So you have to like maybe have proper internet, maybe you ensure that all the importation files you have are all set. Like everything really has to be straight up before you run your model. Yeah, then generalization. This is like these learned policies may not transfer well to new situations. And like, okay, this is more like you're dealing with a model and you've trained it, but it's not really adapting like to different it can only get used to the environment that you've trained it in. So in other words, changing it and taking it to some other environment for it to adapt may also take another time for it. So that's also time, because you're dealing, you have to make it learn everywhere. So it learns in a new environment, change environment, like that, until it gathers all the different environments. Then the computational cost will involve like the deep RL, that is deep learning. Those ones, like they really cost a lot, because computational costs, of course, will mean you have to have good RAM, you have to have GPUs and TPUs. Like you really have to have a good machines that can really handle these models. Yeah. Yeah. So about to end. The emerging trends. So these are some of the emerging trends that affect the future. So we have the multi-agent reinforcement learning. This is like where multiple agents are learning and cooperating. Like I can build my agent, one of you guys also builds, and another one. Let me say we have like people who have different agents, and we like make these agents collaborate. So this is like the future actually, whereby different agents can communicate and share resources. They can actually do something very big. Because imagine something can detect fraud. The same agent can also, let me say, it can read maps. Let me say it can read Google Maps and says the same agent. So a different agent also comes in. Maybe it knows environment of like the environment of like Uganda or Eswatini, whatever. Like it knows, it understands every corner. So when you combine all that, you come up with a very big agent, like a multi-agent. So that's something that's complex, but there are some people who have achieved it. Yeah. So there's meta learning. This is learning to learn faster with less data. Actually, most of the future trends that are coming are like they prioritize less but quality. Yeah, something less but like efficient. So in the future, of course, this is what happens. And also, when we talk about the offline reinforcement learning models, those are the ones that like they just work. They don't need any environment interaction. They can work on their own. You get, yeah. There are also those. Then there are those ones that are safe. Those ones ensure that they behave safely during training and deployment. Then the human in the loop, that one, it incorporates like human feedback from whatever the human like gives it. It incorporates it and takes it. Let me say if you have a bot and you piss off the bot, you get angry at it, it's going to keep that in memory and know that you once annoyed me in this way. So the next time you do it, it knows how to react to you. Yeah. So the frontiers, there's integration with LLMs, then real-world deployment in critical systems, then also more sample efficient algorithms. So then, of course, in the future, you'll be achieving better transfer learning and generalization. Like transfer learning, as I said, it's like you want it to learn something else. You want to teach it something new, and maybe remove what it knows. Yeah, things like that. Yeah. So the key takeaways are reinforcement learning will enable these machines to learn optimal behaviors through interactions. Then, of course, the core components are the agents, the environments. I hope you've all understood all this. And as I explained earlier, the states, the rewards, the policies, and also the multiple approaches like the model-based. I believe you all understood that, the value-based. Yeah, yeah, I believe you. These are like most of the things I've just talked about. And as I conclude, you should know that reinforcement learning is transforming, yeah, how machines learn, like especially in these complex environments. So in these complex environments, a machine can, like by complex environments, I mean every changing environments, like it sees something new every day. Yeah. Today you've taught it how to walk. Tomorrow it's knowing how to climb a hill while running. Yeah. So the next time it's learning how to jump on a hill while somersaulting. So I don't know if you get what I'm trying to say. It's like different environments, it learns and improves based on the challenges that are given in the environment. Yeah. So I think that has been it for my presentation. So before I actually let me proceed. I'm just going to proceed by showing us something small. Okay, this is something that I built. It's an LVM, a large vision model, and this model it has different mod. Okay, let me talk about the project. Let me first start by the project. So the project is called Retina AI. And what it does, its job is to like detect different eye diseases. Yeah, it helps like the elderly people, anyone who is affected with any eye defect. So those who have like eye defects, it's not yet deployed into production, but still under process. But it's so far as a beta version, like can already test. So what it does is it simply detects eye problems of different diseases. It can be like glaucoma, maybe like those blindness diseases, those called eye diseases that cause blindness. So it's just there to scan your eye, because we integrate it in cameras, maybe used by the what do they call the eye, the person who checks eyes? Oh, what? Okay, yeah, I remember the word is ophthalmologist. Yeah, the ophthalmologist is the one who like checks your eye. So this is specifically built to like help help like people having to first go to the doctor to first check their eye problem. You can actually do this at home. You may use a device, because the camera may not be very accurate. Your phone camera may not be very accurate to detect your eyes properly. So it can be integrated in a device that someone can just have, and if they are testing, they just check their eyes on the go, and it will just reflect. It will reflect whatever disease they have. Yeah. So this model is trained based on 4 different advanced architectures. Yeah. So it has like graph clip, it has the graph clip model, it has the visual language GNN, it has scene graph transformers, and also VIGNN. Anyway, I'm not going to take you through all this code because it's really a lot. But for those who have like trained models, you understand how the whole process goes. But those who haven't will soon get started. So this is simply how the code runs. We feed it with a database, by the way. Sorry, not a database, a data sheet. So the data sheet like contains different eyes. Actually, let me first show you how that. Before I show you this whole code, let me just show you the system. Exact system. So yeah, so we deployed this on Hugging Face. This is, what is this error? Okay. All right. Let me just refresh. So we deployed this using on Hugging Face, and we're still testing it and training it more. Of course, it uses reinforcement learning. And this is just the simple dashboard. Yeah. For now, it can only predict a disease. Let me say, so it has these different functionalities that allow you to like use the webcam to detect, or you can just upload a picture. It can be a scanned image of your eye. So they can scan it, then you can use the system to like detect it. Then of course, if you've maybe pasted something on a clipboard, you can bring it. So let me say I have a very variety of data sets here. Let me say I just put this here, then submit, then it will process and detect. So these are like, so this is now glaucoma. So it finds out the exact category of the disease. Of course, if it's a normal eye, it will also tell you it's a normal eye. So of course, we are yet to improve it. Let me try out one of these. See? Yeah, still glaucoma. I'll try something else. Yeah. Just a different data set. Okay. Let me try out this. This is like a normal eye. And you can submit this. Doesn't check submitting. Oh, this one is saying it's cataract. Actually, so this is just how the system works. And of course, we are improving it with time. We want to first train this model to become so good to the point that it can, its accuracy is not as good as we expect, but we just want it to, like, of course, we also have the app version. I can't show you that from here. It's an APK that is just on a phone. But yeah, simply, all you need to know is that it is a reinforcement learning, and we train it over different kind of data sets, not only one. We get the different data sets from it's called RFMID, Retina Fundus Medical Disease Institute, something like that. So they keep bringing new data sets. So you have to keep training it so that it learns to, like, take in different things. Yeah, because the more it learns, the more accuracy it gains, and the more it improves. So maybe we could have a hands-on session, I don't know, in the future to, like, show you how all this came about. Because explaining everything here is kind of, it's like a whole class of its own, right? Yeah, so these are like the graphs. So we have a lot of cumulative distribution graphs and frequency distribution graphs to, like, okay, these ones just validate and show us, like, how these different models, because we have 4 models, remember. And I told you that we have the graph clip, we have the visual language GNN, scene graph transformer, and VIGNN. So having all those models really, okay, these are models that you just have to, like, understand, like, okay, know how they work. Yeah, the graph clip is basically for graphs. Yeah, it just displays the graphs showing, like, maybe like a percentage of people in a specific area, maybe like how many have this disease, how many have, you get. So all those will be embedded into, like, the real application. So the graphs will be displayed based on location. Let me say we've gone to a different location, we scanned around 200 people, and let me say they have this eye disease. So the graph will automatically put that and show that now these are the number of people that are affected with this disease. Yeah. Then the visual language GNN, this one is more of like visuals. And for it, it's trained, it's one of the most important models, because it allows you to, like, detect exactly what that specific model does. I mean, what that specific eye disease is. Yeah. So it's the one that captures the eye defects. It's the one that tells you that this is not this, this is this. Then the scene graph transformer is for it. It's more of like displaying. It's also for graphs, but for it, it's not just about percentages or, like, diseases. For it, it shows the performance of the model. How is the model performing over time as you've trained it? Yeah. More so with the the VIGNN also does more of the same. Yeah. So this is something that's still under. Of course, if there are some engineers here who are, like, ML or experts and would love to jump on these projects, I wouldn't mind. You can come and we cook something up. Yeah, because I get held up with other things, and sometimes I don't really give this much attention. It's like a side project that I'm working on. Yeah, so I believe said so much. I believe I've said so much, and first jump back on that. See if I'm not talking to myself. Okay, wow, we're all here. Yeah, so I think that has been it. I don't really have much to add on. I just want to now hear from you people, and I want to get a few questions. I want to get a few interactions, because I think I've spoken the whole like for a whole 60 minutes. plus, yeah. So yeah, guys, that has been it. I hope we've learned something, and I'm welcoming, yeah, a few questions. You can maybe like introduce yourself, tell me about yourself, and then you can ask something. I'm ready to answer. Yeah. Hello, are we there?
Hello, Johnson. I believe we're
Yeah.
here. People, this is your chance. Yes, please
Yeah.
do ask questions. Thank you so much. I think Johnson, you can pick. You can see them by the hand, then
Oh,
you interact with them. Yes.
okay. Yeah, yeah. Oh, awesome. I saw, is it Mayenzi Nkalugi? Yeah, yeah.
Yes.
Yeah.
Hello, everyone. My name is Mayen Sangambule. I'm a student at UNESCO. I'm doing my first year. I want to ask, in fact, I would like to ask you to make an example of maybe a complete machine that will learn, and just maybe you could explain how it learns step by step using the components, starting from agents, action, and so on.
Oh, okay. Oh, wow, that's nice. So, like, you want to like see the whole process of
Yes,
like the
maybe
whole.
if you could.
Okay. I think we can do that. We still have time. I think I can just show you like a small thing. Okay. Let me first take these people's questions. Mine's, then I see they may have direct questions for now. Then I'm going to come back to that. Okay.
Okay.
Yeah. Yeah. We have Mbuza. Sorry, Mabuza. Melu. Okay, that name. Okay, but he's called Mabuza. Yeah.
It's
Please
me
go on.
too.
Mehluli.
Okay. Surely. Okay.
Yes, yes.
Yeah.
I don't have a question, but I
Yeah.
would like to thank for what you have
Mm.
just given us. I believe that's your project. I mean, that's your project or your model. I've learned something.
Okay.
Yes,
Nice.
as you were teaching, I was busy searching on my laptop, trying to figure
Mm.
out how can I learn what you have just said to us in simple steps. Now I get it. What you're really saying, I get it now.
Okay. Wow.
Yeah,
So
yeah.
yours
Just
is
big,
yours
big,
is more
big
like an
thing.
appreciation. Yeah. You saying?
Yeah, it's more like an appreciation.
Okay. I'm happy you've
Yes.
learned. I'm happy you've learned
Yeah.
because you have to most people like want to like jump into like the technical part, but they don't actually know how everything works in the back of their heads. So most importantly, when you're developing, when you're building, whatever you're doing, always make
Mm-hmm.
sure you first have, they call it like a wireframe, right? So have that wireframe of how things work. It makes it easy to understand like what you're building. Yeah. Yeah. So that's exactly what I
Okay.
wanted us to like know, so that when you go out there, it's easy for you to like do something practically. Yeah. So
Um,
yeah. Thank you. So we have Francisco Go. You can also ask, please.
Yes, how are you, sir?
I'm okay. Thank you.
I'm okay too. I wanted to ask something. I'm a final year student at UNESCO. I'm writing
Okay.
up. I've heard this is about a project which I want to work on. So I wanted to know, if it were you, how about would you go about it?
If you have a project you're working on, Yeah.
Yes, it is. Yeah, and it is a requirement that once you reach your final year, you have to write a project. So I have this project
Okay.
that I'm working on, which analyzes like videos,
Mm.
and then it's I want to create something that can actually can translate videos, something that can actually translate certain like maybe anime. You can translate the anime, and then you can download the translated version, and then you can paste it over the version that you are watching. Because most videos that like they come in different languages, maybe Japanese if it's from Japan, Chinese. So you find that most of the time people don't actually have the it takes a long time to have the translated version. So most of the time you find that people they are watching the videos, they are watching the on subtitles. If some have subtitles, most don't have subtitles. For example, for the ones in China, they don't actually have subtitles. So I wanted to work on it. Wanted to do something that I can actually translate, that can instantly translate the videos. Then you can go and download maybe the translated version, or maybe you can go and download something that you can paste over your videos. Then it's a it's just something like that. So I wanted to know if like you were give me direction. How about I would go about structuring the data?
Okay,
Full
that's a
cycle.
nice question. Okay, but that's really actually a nice project. It's like more of like dealing with end-to-end multimodal translation. Like those are like multimodal translation models. Like they do translations to video to audio, or text video to speech. Ah, okay. I all I can say is that's a nice project, by the way, because so many things nowadays, like want to transcribe, right? You want to
Yes.
transcribe stuff from videos, maybe from different languages. Yeah, but
Yes.
I think you should check out something like lip sync. Yeah, try searching about lip sync and how multimodal translation works. Yeah, maybe read their docs, and also maybe you can use Whisper. There's a platform called Whisper. It allows speech to text if you want to integrate them. Then there are so many other and multimodal translation models. I've heard of one called Transformer. Yeah. I think you can check that out. For it,
Okay.
Transformer uses like audio, it uses visual, and also uses text features. So it has audio, visual, and text features for its translation. It's actually a good model. So you can try searching about those models, get to learn them. Um, Maybe if there was a podium where I could share some links, would be good. But check those out and try like reading much about them and how to like embed them into your project, right?
Okay.
Yeah,
So Whisper
yeah,
and Transformer.
yeah. There's Whisper, there's Transformer, there's MSLAM. MSLAM is a multimodal speech and language alignment model. So MSLAM allows you to deal with speech and language alignment. So it also helps in like translation actually. So let me say someone is talking and I want to change that to, like, those YouTube videos, like this guy
Yeah.
called Messi, the footballer, when he's speaking in in Spanish, it automatically translates to English, right? So those guys be
Oh, I see
using
that.
MSLAM. Yeah, that's MSLAM that they add for doing that translation. Yeah. Yeah, but there are
Okay.
very
So,
many other models. Yeah, you can try out. You can try out checking out others. Yeah.
okay. Thank you,
Okay.
sir.
All right. You're welcome. I have another question from the why do you people have so hard names? Fezile Dlamini. Okay. I think I got that. All right.
Good day to everyone.
Yeah.
Yes.
All right.
I am Dlamini, schooling at UNESCO, doing engineering. So
Okay.
here I was interested on your invitation on the project that you are currently doing, the one about eye diseases and for sort.
Okay.
Yes, and
All right.
on your invitations, I'm so interested, and I want to know how can I engage myself and then more about it.
Okay. Yeah, you
Yes.
can actually come. I think some Kelo, you can maybe some I have contacts with some Kelo. Maybe he can forward you, and we can get to talk, and I can actually onboard you to learn a lot of stuff. I actually need, if I can get like 5 people from here, that would be good. Yeah, to work on this, because I barely have like a lot of time to be on this project. Yeah. Yeah. So I think you can reach
Yes.
out to
Okay.
to Sam Kelo, and he can like show you. Okay, he can like forward you to me. Then yeah, can talk and can be able to like add you up to the team. Yeah.
Okay. It's just that I don't think I know Samgelo that much. I don't know how can I get contact with Samgelo.
I have pasted my email in the chat. Please get me there.
Okay. I will try much to. Okay.
Okay. Yeah. You can actually reach him via email. Okay, that's good. All right. So, is there any other question from anyone?
No,
There's no one. Okay, I see Salman, I see Laney. Yeah, Laney, you can ask. Please.
Sorry, thank you very much for the presentation. I don't know if you got my question about the
Yeah.
level of Python to build the models, and then also for the GitHub links for collaboration on your project. I don't know if that's been addressed or not.
You're saying what? Sorry, I didn't get you properly.
Okay, I asked two questions. Like, do you need to be an intermediate Python programmer to build some of these models and the algorithm that will display today? That was one. And two is I actually liked your project. I could see how it is, and it's so simpler than other. The interface is just very cool for me because I've seen other programs that are dealing with disease, and they just tend to cluster it up too much. So I'm really interested in it. So I'd ask for your GitHub link for collaboration on projects and further projects. Those are the two questions that I asked about. Thank you.
Okay. Yeah, so I've just sent my GitHub in the chat. That's my GitHub username. Yeah, so to answer your question, it's you can actually if you're a Python programmer, then I want you on my team as a must, because almost everything that we do rotates around Python, and yeah, I'm not saying the rest can't come. Of course you can, but like we all know Python is more like the foundation of data science and machine learning. Like before you want to dive in, you at least have to have at least the basics on Python programming, and then you transition to like different other things like Django. You start doing all those things of matplotlib. Like, trust me, if you're Python, you're on a right track to like learn ML and build your own models. You build your own models, you deploy them, and after deploying them, you share them out there. Like, don't keep stuff on localhost. You keeping stuff on localhost is not good. When you build something, you share it, pitch it, take it to a hackathon, take it to whatsoever, and ensure that different people know about it. Because like now I've told you about this project and you now know about, there are some other projects I have, but they're a bit private. I'll share with people as I get to know them. But yeah, just if you have a Python background, you're good to go. Even if you have React JavaScript background, you can still come in, because usually these user interfaces are good for React devs. Like the way you saw that interface, it's still actually that interface is just simple, and it's just a small dashboard. Okay, for now it's meant to be like that because we don't want too much crowding, but of course it can always be improved, and that's the reason I need you guys to like come and you come and shine and showcase some skills of front end and stuff like that. Yeah. Right. So is there any other question? I saw someone with a question in the chat. Someone said nice presentation, thank you. Oh, I shared my GitHub link, Salman. Collaboration. Maybe I see very many people want to work. Sam Kelo, is it okay if I like share a contact or something? I don't know.
Yes, yes, please do. Please do.
So that I don't give you that burden.
Yeah, please do.
Okay, let me share my contact here so that it's easy. My WhatsApp. Yeah, that's my contact. It's a Ugandan contact, and I don't know. Yeah, you can reach out on that. Please, when you're reaching out, be serious. Not in a bad way.
Can I say something quickly?
Yes, please. Yes, please.
I would have preferred you share your LinkedIn and not your WhatsApp, just to be safe and avoid disturbance. I think LinkedIn is more of kind of you can filter people from there and filter real people that actually want to connect with you. So then from the LinkedIn, if they sound so serious and very good, you can now take them to WhatsApp.
Okay.
All right, then.
Let me get my LinkedIn. Just a few. I'm sure there are already people who have inboxed me.
Yes, for that also don't have access, I can also share the link to your LinkedIn as well.
Yeah, that's what I'm that's what I'm waiting. I think it's better to use LinkedIn. Yeah, as he has said, because I actually don't be on WhatsApp most of the times. So yeah, LinkedIn is fine. Yeah, I've actually shared the LinkedIn. Yeah, I've shared the LinkedIn. Please reach out to me on LinkedIn, then you can talk more. Those who already have my contact, it's okay. You can still reach out using a contact. I wouldn't actually mind. I wouldn't mind. Okay. By the way, there's
a hand.
Sorry?
There's a hand. I think it's Lenny.
Yeah, Lenny, you can say something, please. Yeah, Lenny.
Hi everyone.
Hi.
I just have a small question. It's about the model thingy. So say maybe you made an example about Spanish footballer about how the it is translated, the language is translated that fast into English, things like that, right? So my question is, say, like, is there like a model maybe, or a way to create a model whereby it can translate maybe a video or audio? It doesn't really focus like on the language part. Let's just skip that part for a bit. Maybe you want to like translate from Audible. I don't know how to put this, because there's something that I've noticed lately, and I'm just still trying to find my way around it, because I've really noticed that in everything that we're doing, there's a certain group of people that we're leaving behind. Those people being the people that use like sign language and everything. So my question is there like a way, or is there maybe a model that we can use to help those people out, so that they're not left out, in the sense that if you there's I don't know if you get my question.
Yeah. I actually get you. I've already processed. Yeah. Just to start with what you had said, it was about sign language recognition. Most times it can be video. Maybe it can be, sorry. Okay. I actually know someone who has worked on such a project, sign language, but usually sign language, it deals, if let me say someone is using sign language and I want to understand them, you can think of something, like come up with something. All I can suggest is you can sit down, come up with something, and it can be like, it can be a model. Of course, you'll need the models because you need to train them based on different sign languages. But it can be trained with OpenCV. Yeah, it can. Yeah. So you can sit down and think of like some different models. I personally have not actually worked on sign language project before, but that's actually a good thing. You can look into CNN models, because CNN models are good at looking into images. I don't know what stack you use, but you can look into different models and get as many data sets as you can based on different sign languages, so that you train this model to know almost every sign language and gets perfection out of it. There's very many data sets you can look up online to get them, but if you can use try out some models of like CNN, because I know CNN can extract like special features, like maybe like facial impressions, body positionings, and hand motions. So those things, that model is one of the models that can like help you, and it's one of them. I don't know about other models that work on that. I won't lie to you. I want to be very transparent, because I only talk about what I know. Yeah, but you can make research about visual models that understand visuals, so that you implement them in your project, and make sure you have good data sets, because trust me, models are the easiest thing to work around, but data sets are the ones that make you stand out. That's why there are some sites that actually don't give out data sets for free, because data sets is data, right? And once you have access to data, you can do anything. You become unstoppable, because actually you become a step ahead of someone else who has less data. So the most important thing here is getting those data sets that that are for like sign language and all that. Make sure you have good data sets. You can even create your own data sets. By creating, I mean you go search for already existing data sets and combine them to come up with something that you works for you, or something that is advanced compared to others that exist. Then once you get those, train your model based on those data sets and feed it with proper accuracy. Then get a prototype that you can use. It can be a camera, you deploy it maybe on Hugging Face, whatever platform, and ensure that it can detect the person. So when you get a different person, let me say, to do those sign languages, to act as a demo, it should be able to give accurate feedback of what that person means. So it does that. You can be sending back in the form of speech or text. Doesn't matter, because that's the point. Then you complete that and reverse engineer the whole process, whereby you can do the reverse and ensure that you can be able to have it work both ways. And once you've achieved that, you already have a working project that can actually be implemented out there. Yeah. So that's I think what I should advise is focus more on the data sets, because if you've encountered if you've done a lot of stuff, you can use anyone can build a model. It's not that hard. Anyone can do what I do. But what makes your project unique is what matters. Like, find something you can integrate AI, whatever it is. Find something that actually is going to make your project stand out, so that when you go and to like organizations that really want it, by the way, the vulnerable organizations, let me say organizations for the vulnerable, would actually buy your idea, and yeah, you'd find yourself doing something big for the community. Yeah, I think that's all I can tell you. All right. So there's someone who asked a question earlier, but your question was nice and I liked it because it was practical, and I like the practical bit, but I have an issue. The issue is time, because I have to be up for another call right in the next few minutes from now. And the practical session may kind of take some time, because I know myself, when I start doing stuff, I really want to do too much. So I may not end up finishing and to be effective. But I believe we can have maybe another session, and I will show everything in the future, in the near future. Not we can have another session, so that I just come. You come when your mind is knowing you're going to do hands-on, right? Yeah, but maybe I can just recommend some platforms. Sorry, yes, Samkel.
Mr. Johnson, sorry for the interjection. I wanted to recommend the ones that we had conversed about earlier, that maybe you can just do the project and you post it on GitHub. Then when the times, then I'll show the participants. Then when the time's right, we can then try to organize maybe a session like where the participants can just ask questions, assuming that they have tried to implement it and find some problems. Then you come and clarify clarify those problems. But yes, as you say that. It will not be next week, but I will try and make that arrangement.
Okay. Yeah, actually, that's a good one. We can we can use this project. I can have a session on this whole project, and we can maybe I can explain to all those who are interested to learn from it and get some ideas as well. Yeah, I think we shall do that.
And just one last one from me before you knock off. I know that you are rushing for another session. Just a question: have you ever worked in adversarial environments?
Sorry?
Have you ever worked in adversarial environments?
Adversarial? I didn't get that one.
Adversarial environments.
Oh, adversarial.
Yes.
Ah.
If you have, there was an experiment that I was just doing a few days ago. So then I had an issue that the agent was busy overfitting the reward signals, and then what I did was that I tried to find a way around it. Like what I did, I tried to improve the Markov assumptions, but it wasn't working according to my wishes. Yes, I still do some research. Then I then also try to implement the partially observable Markov decision process, but still I wasn't getting that result that I want, because in this type, in reinforcement learning, when it comes to the adversarial environment, I often face this thing besides exploration and exploitation. That yes, I wanted the agent to find the right step, but I also wanted the agent to find the right legal and fair step. Because because the agent can find the right step, but you find that it's not compliant to the rules that we currently have. Yes, it is the right one according to the agent, but when it comes to compliance, you find that it's not compliant. I'm not sure if you got me there. I am still doing my research, but if you have any ideas, I think you can shoot them.
Adversarial environments. I last worked on such way back. Adversarial environments. So you tried training the agent, but like was it against you, or did you manage to achieve like what you wanted? Oh, it's still not it.
As for against me, no. It wasn't shooting me, but I was simulating an environment like whereby the agent, it is going on the right direction, but not necessarily in the legal and the compliance direction. So I was trying to find a solution to that. And from the research papers that I've read, they were implementing this concept called the partial observable Markov decision process. So, but when I tried to implement that, it wasn't. It wasn't giving me what I was hoping for, or maybe I implemented it wrongly. So, I just wanted to know if you have worked on that, because the problem that I found in most people that I have communicated to is that we build these models and we build these systems, but then when it comes to implementation, to like a full scale implementation, you find that there's the data protection rules, there's the system rules, and despite that, these models are intelligent, but they also have to be compliant with the best security measures that there is, and also be compliant to like all of these data protection. And I saw that you are building a health solution. So that solution, it also has to be compliant with the health standards that they currently use, or otherwise when you pitch it, maybe they won't accept it because of the standards. So I was trying to see as to how do you normally incorporate that.
Oh, okay. Oh, wow. Okay. 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 Usually, these adversary environments, like especially in reinforcement learning, like okay, whatever it is, doesn't matter. But like they're usually like very, very, very like sensitive. Yeah. And that sensitivity is what is because like now when you're training your model, I'm sure I believe in case you're training, you may end up finding some difficult cases, and maybe
yes.
Yeah, maybe some may even include attacks. Yeah, I don't know. I don't know if you've surfaced them. Yeah, so
yes, I think I have worked on that.
Oh, I think you should incorporate some important strategies when working on those models. Like, okay, I don't know if you've used the DynaQ strategy of like planning and simulation, whereby it helps a model to like, as I explained it earlier, for it mostly like decides on the best path. Yeah, so like you're training your model, it's having a lot of constraints and many mistakes that are happening. One thing I can first advise you is ensure ensure to like check whether, and okay, like what I can say is like test your model. Yeah, because usually there's what they call stress testing. I don't know if you've heard of stress testing, but
yes, of course.
You've heard it. Yeah.
I tell you with it every day.
Oh, for yeah. Now I'm talking to someone who understands what I'm saying. Okay. Yeah. So I think you should do a lot of like tests, and also not. Oh, I'm sure if you've trained it like many more times, like how efficient has it got? Like, is it improving, or it's just backfire? Like, because I know there's so many cases where you're like doing adversarial training, and maybe you're finding challenges, like some things are just not you trained a model, because I remember I trained a certain model, and it was again trying to, like, as if it wants to train something else. I don't know if you get what I'm saying. You're training it, but again, yeah, it's some far-fetched stuff. But anyway, all I can say is like just keep doing fluent tests and stress tests, and also I think I think you should just show me how that thing is. I don't know. I want to just see it. It would be easier. And I really see the real challenge here. Because I last worked on such a project of adversarial, I think in like 2019, man. It's been a long time. So I need to like I need to like look back a bit and try to like backtrack, find like all the potential loopholes, you know? Yeah, but I think we'll talk more about that. Maybe you show me while explaining to me, and I see where I can help. Yeah.
Okay, all right, no problem.
Yeah.
I think yes, I think we can have that session, and yeah, we will continue to communicate, and
Yeah.
yeah, just to not waste everyone's time, and also keep you from your session. So for me, it's that thank you so much for being here. Um, I'm sure that the people have learned a lot, and some of them, as we speak, they will be working and collaborating. And that is what we want, and that is what we wish, that we have that continental collaboration. Then from the participants, please don't forget to fill in the feedback form so that the people from the organizations can know as to how to better improve next time. And just one last one from the person who was working on multi-modal from the person who was working on multilingual. Try to also search on Huawei's stack. They are very, very good. Their AI models are also very, very good. So try to search there as well. As we speak, last time I was there, I think it's just in June. They have this feature that you can call anyone anywhere in the world, and you just hear them right. So just please go into their platform and see as to what kind of models that you can grab in there. Then you can distill them to your specific task. Yeah, I think that's it for me. Unless someone has something to say, please do. Otherwise, thank you so much, people.
Sorry. Please, can you say again